wondering if we should wait one more minute. I think we'll get started. Gives lots of time for questions. And I'm going to mute myself and take it away.
Okay. Thank you, everyone, for joining. And I'm Peng. I'm a staff engineer for Ant Group, and today I will introduce our work on image acceleration. We have a project called Nydus, and it has key feature to speed up the image pooling process, and also we want to emphasize on end-to-end data integration. And this is a project, open source project, and co-developed by Alibaba Cloud and Ant Group. So this is today's agenda. We'll talk about a little bit about container image, and also we will cover. We will cover what is container image and the drawbacks we saw with the current OCI specification. Then we will talk about Nydus container image service. That's the main topic today, and last we'll talk about a little bit about our future plans. So first to you about container image. When we look at a Docker, we mostly separate it into two things. The first one is it is a container. It is fast, lightweight, and isolated. That is how we run an application in a container. And another thing is an immutable part of the container that is called an image. And the key feature for it we see is it is very easy to transfer between different run environment, and also it is immutable. So when we build it, when we verify this all these things inside of a container, we can ensure that it is run similarly across different environment. So that's the main part we want to talk about it today. And so when we look at a container image, it involves two parts. The first one is a read-only container image, and above that we usually put a read-write layer, that is a container rootfs, and the read-only part is usually made up of several different read-only layers, and this is a OCI image structure. An OCI container image usually comes up with the container index.json, and it will point us to a manifest.json. These are all JSON files, and a manifest.json can have many can have two things. The first one is it has a config.json file that is used to describe a container image, what is inside it, and for example, what application should be running inside of it. And also another major part of the manifest is a description of all the container data layers. Right now, it is usually many tar layers, and all these tar layers together with the config.json are all hashed with SHA-1 algorithm, and each of them can be together combined into a manifest.json, and it is also hashed. It is SHA-256, and all these things comes up with a Merkle tree that is usually called a hash tree. So when we identify a manifest.json, we identify it with a hash value. Once we specify the hash value of a manifest.json, we specify all these things, all these config.json, all these tar layers, all these are hash checked. So we knew that when we have a hash checked manifest.json, when we distribute it anywhere, we know it is the same thing that is being distributed. This is the main part of why an OCI image is called an immutable infrastructure. But with this OCI image, it is widely used in the industry for many years, and we see some drawbacks with it. The first one is, before we start a container, all these images must be fully pulled and decompressed to the local file system. So this can be very slow if the image is large. And there's a paper by Project Snacker, and it says there's only 6.4% of the container image is actually used when we run a container. So it is really a waste of time to pull all these things locally. And also the consequence is obvious. The container startup time is very, very slow, especially for the first time. And another drawback of an OCI image is the duplication. The duplication right now is at the container image, the image layer level, and it is less efficient. Firstly, when we modify a file's metadata, it will cause the file data to be saved again in the new layer as well. And also, if we modify the same file multiple times in multiple layers, the same file will be saved in multiple layers. And when we pull this image locally, we will have to download all these layers and all this data for the same file multiple times, while only the last modified file data is actually usable for containers. So if we modify a file twice, we will download it twice, but only part of the data is actually usable. We waste half of the bandwidth at least. And also there's another thing with it is, when we delete files and directories, these files and directories are also still saved in the previous layers, and it will be downloaded when we pull an image, but it will never be used. It won't be used by a container at all. Also, the another topic of the container of an OCI image is that there is no runtime integration check. That is one of the things we want to tackle, the end-to-end data integration. So when we pull a container image, it is a tar.gz, it is a gzipped tarball, and we will have to unpack it into a local file system before it can be used by containers. But after the tarball is unpacked to local file system, all these images cannot be verified. Remember, we say container image is immutable, and we want to make sure the same thing is used everywhere for the same container image. But after the container image is unpacked, the data is not protected by the OCI hash values, so it cannot be verified at all. And as a consequence, what if someone modifies the unpacked file directory intentionally or unintentionally? We cannot know. We never know. And if we run the same container multiple times on the same host, we cannot really know we are running the same thing multiple times. So from our point of view, this is a big missing picture of the container image supply chain security. And we want to tackle it with Nydus. So with all these drawbacks, there are some there are some prior community works. The first one is Dragonfly from CNCF and Kraken from Uber. They all used P2P based method to speed up the container distribution. But the drawback is obvious. They they still have to distribute all the entire container image. And also, there's CERN VMFS from CERN, and it runs by the name. We know that it runs on the CERN VMFS file system, and it cannot really work with independently with different environment. And also, there is a Stanker project from Wisconsin University, and it is using the storage layer snapshot capability. But still, the drawback is obvious. What if your storage layer do not have a snapshot capability? It cannot do any snapshot. How can you use Stanker? And still, there's also the CRFS project from Google Golden Build team, and its main idea is to keep the layered format and in a OCI compatible way, and also it split up the metadata and data in each container layers. And the drawback is it is still it creates a fuse endpoint for every layer. So if we have many layers in the same container image, we will have to have many fuse endpoints, then it will kill our performance. Also, there's more innovative projects such as Filegram from NTT and UML OCI from SUSE. They break out the layered file format and separate image data and metadata. Let us respect all this previous work and learn from them and try to improve the image community with a different approach than we will talk about soon. So what is a Nydus image service? So firstly, we make sure container images are downloaded on demand instead of having to download all these bits before running a container. Also, we support chunk level data duplication, so the disk space is reduced to a certain minimal level. And also, we learn from using UML OCI and Filegram. Sorry. We flatten container image, the image metadata and the data, so we remove all intermediate layers. And also we support optional local cache with data prefetching, and also a rate limiting method to prevent the prefetching thread killing the disk speed. Also, we want to emphasize we support end-to-end image data integrity, and the Nydus image format is compatible with the OCI artifact spec and the distribution spec. That makes us able to store the Nydus metadata and the data on a regular container registry. So this is the Nydus architecture. In the middle, there is a Nydus image service that's a US-based file system daemon. And this file system daemon provides two transports for container to access. So it can be used with a fuse endpoint. It can be used with a VertiFS endpoint. So the same Nydus daemon can be used by normal run-C container and also virtualized containers such as Kata. And within the US-based file system, there's file system data and file system metadata. Both of them are saved in different backends, such as object store and even NAS. And also, we natively support Docker registries. And we can have optionally a P2P network such as Dragonfly in the middle between a Nydus daemon and the registry. And inside the Nydus daemon, there can be an optional local cache. So when we download after we download a chunk of data local to the local file system, we can avoid the future network access by just accessing it locally. Right. So this is a Nydus manifest list. So we make use of the OCI image spec to append a Nydus image after a normal OCI image. So right now we identify this with OS store feature bit, and it can kind of works like an annotation. So it says it is a Nydus remote image, and we have patched container D to identify this Nydus image. If we are running an unpatched container D, it can only see the upper one, the original OCI image, and it works by just pulling the normal OCI image. And if we are running an patched container D, we can use it to identify Nydus image and say, okay, there's a Nydus image. We can use it to speed up the container pulling process. And this is how things works when we have a patched container D. If we do not want to use it, we can just save a Nydus image and the separate manifest, and such as this one. So this is a Nydus manifest. It is the upper or the lower one here, and also it can be identified by a container name and tag. And inside of it, it has a config. Then that is the normal container config in the normal container manifest. And also it has many layers. It has a Nydus bootstrap. It has a Nydus bootstrap layer, and also it can have multiple Nydus blobs layers. So with this kind of manifest, we can run Nydus with a modified upstream container D with Nydus capable container D step shorter. So this is the Nydus image format. So inside every Nydus image, we have image metadata. It is a Markov tree inside of it, and every node has a hash. Here in the picture, we see SHA. Actually, we are defaulting to Black 3 right now, which is way more faster than SHA. And every node has a hash value, and a directory's hash value is a hash value of all its children, and a file's hash value is the hash value of all the chunk data from within the file, and every chunk has a hash value as well. So when we save a file's data as a chunk in a shared data layer, the same chunk can be shared by a different Nydus image if the two chunks have the same hash value. And all the sharing is optional. Can be right now it is not configurable, but we want to make it configurable in the future. My keyboard must be broken.
Yeah, we have questions, but if you're wrapping up, we can wait till the end, or I can ask.
You can ask the question.
Okay, great. So the first question: do you plan on getting support for this in Podman or Cryo or Builda?
Yeah, sure. That's in our roadmap. Sure.
It's on the roadmap. Great. And this is open source, right? That was a question.
Yes.
But yeah.
Yes.
And Nydus Snapshotter, that's also open source?
Yes.
And another question, this can only be used with Fuse by Run C. Is there any plan to not pay the price of Fuse performance?
Not right now. We have some ideas to reduce the our performance overhead, but currently we stick to the US-based implementation because it is more easy to implement and to iterate all this or the development when we have the when we have the format fixed and when we have wider community support and agreements on, for example, if this format is agreed and the OCI V2 image format, we can start to consider a kernel implementation. But right now, I think the US-based implementation is better, and we might change the format and implementation, and the community discussion grows.
I see. Another question, if I create an image, will I need to create two images, the original format and the Nydus format?
This is actually optional. We can convert an existing OCI image into a Nydus image. So in that case, there's only a Nydus image, and we can also create a manifest list that lists the two images in the same main list. So that's how that's here. Yeah.
Yeah, that was the next question actually. Can you convert other container images to the Nydus format? So you answered that.
Yes. We have a Nydusified tool to do the conversion.
And just one more question, then you can go on. If I use two different containers with the same file, does the kernel see them as the same inode on the same file system? In other words, the file is in different images? Or
no. Since we are behind the Fuse, actually inside the Fuse, the different image is different mount point, and naturally there are different inodes.
That's all the current questions.
Okay, so I'll move on. Sorry, there. So then this picture shows how we do end-to-end data integration. We said earlier that after a container image is unpacked, it cannot be verified. So with Nydus, we actually do not unpack at all. We have a local cache, and each chunk is saved in the local cache. So this is also optional, I have to say, because the hash checker consumes some CPU and time. So when we access a file's data, the chunk is read by the Nydus daemon, and the hash value will be checked optionally. And if the hash value doesn't match, Nydus still will fall back to the registry to fetch the same chunk and return to the application. So by this, we make sure that all the data we return to application is actually checked. So this is a container startup benchmark, and actually this is done a long time ago, but the results should be similar with the current version. So the green line are the OCI V1 image, and the orange one is the Nydus image. So when we pull OCI image, the time both pulling and starting, the time grows and the image size grows. And with Nydus, when we pull a Nydus image, we just pull its metadata layer, and it will be done within 1 second. And the container startup is also very, very small with or below 4 seconds, and are not more consistent than the OCI image. So this is our future work. As I said earlier, we plan to implement a flexible data duplication level. Right now, we have a image level or image layer level sharing, and inside each image layer, we can across each image layer we can share different chunks, and we want to implement different method here. But right now, the data duplication is not our first priority. So we just make sure each layer is shared. And also we want to integrate with BuildKit. We have some POC in-house, but it is not yet ready to be open sourced, but we want to work on it as soon as possible. Also, we are working with the Harbor team to integrate Nydus inside Harbor. So in future, when a user push a container image to a Harbor registry, it will be automatically converted to a Nydus image, and it is usable if the container D used by the user can identify the Nydus image. Also, we want to integrate with other container runtimes. Right now, we can only work with container D, and we provide an open source container D stem shorter. We will look at how to integrate with Docker and CRI-O, and of course Podman. And also we are working with Steve Lesker to adopt the OCI artifacts manifest specification and make Nydus image format, Nydus artifacts manifest an example of his OCI artifacts manifest specification proposal. And last, this is our future higher goal. We want to serve as a reference implementation for the OCI V2 image specification. We had some discussion with the OCI community, and I believe the OCI V2 image spec discussion is still going on in the OCI community, and we want to be part of the future land of a OCI image. So that's our future work, and thank you. We have open sourced all the code under the Dragonfly project. The Dragonfly is already a CNCF sandbox project, and we open sourced it, and we open sourced Nydus as part of the Dragonfly project, and all these bits, the runtime part, all this image conversion code, and the container D stem shorter code are all in the same repository. We will try to upstream the container D stem shorter part when after we discuss with the container D maintainers, but the plan is to move the code to a better, more official place. And if you are interested, there's a link to all our documents, and it shows how it has some tutorial how to run Nydus, and also it has all the designs, high-level designs of Nydus there as well. So that's all for my talk.
Oh, thank you so much. This was a really interesting talk, and I know I see a bunch of people who would love to talk about it more. I understand you have a conflict, but perhaps they'll reach out to you, and you guys can discuss more when you have time.
Yeah, I will stay here and watch a StarGZ talk and join the container image pooling discussion today. Yeah.
Oh, great. All right. Well, see you later, and thank you so much.